Okay, semua dah ada?
Tak sure sir.
Okay. Kita apa ni? I nak mula. So I'm going to record this lecture. So mungkin apa ni? Kita lecture kejap je lah hari ni Okay. Recording. Okay. Now I'm Assalamualaikum and good morning everybody. This is our first meet online. So I hope you can hear me clearly.
Sure sir.
Yes sir.
Betul-betul,
Yes sir, clear.
Okay.
Clear sir.
Right now we have 15 and most probably that the whole class is about 26, right? So about 10, about half not in. So I hope they will be later. And I hope you can mute your mic so that no what do you call it, noise coming in, so that everybody can hear me clearly. Okay, and to start with, I'm going to do some introduction. Okay, introduction to the class in terms of the subject. So I'm going to share the slides. I'm going to share the slides so that you can see. Okay, can you share the? Can you see the slides?
Yes, sir.
Okay.
Yes sir.
Yes
Pak
sir.
sir.
No sir.
All of you are in the class Introduction to Electrical Engineering, yeah? EEE3352. I'm going to show you the course syllabus for this semester. The textbook is Fundamental of Electrical Engineering by Giorgio Rizzoni. So all of you have downloaded the textbook. And we will cover chapter 1 and 2, which deal with the units, definition, experimental laws, and simple circuits. We'll cover chapter 3, analysis technique, which is will be nodal analysis and mesh analysis, source transformation, sampling circuits, and all those. Then we go to chapter 4, which deal with inductance and capacitance. Then after that, chapter 5 on transient response of RL and RC circuit. R is basically a symbol for the resistance, L symbol for inductance, C symbol for capacitance. So we'll deal with the transient responses of RL and RC circuits. And then we'll cover chapter 7.3 and chapter 13 on magnetic circuits and transformers. Mostly the slides will be on chapter 13. Then finally, we'll cover chapter 14 on electrical machines, AC and DC motors and generators. So those are the chapters that we will cover in this next 14 weeks. So this is how the assessment of the course will be done. Your assignment is about 20%, quizzes 5%, test 1 10%, test 2 15%, and final exam of 50%. So total is 100%. Test will be in week 6 or 7 for the test 1, and test 2 will be in about week 11 or 12. Then after that, we'll have a final exam. So normally, test 1 will cover up to the chapter 4, the inductance, or up to the up to the response, transient response. And after that, test 2 will cover from the transient response until to the end of the semester. For the final, it covers all, starting from chapter 1 until the final week to the DC motors, DC and AC motors and generators. Okay? So that is the how we are going to assess your performance. This is if you do this classroom or the face-to-face. If basically the lecture about 2 hours and tutorial of 1 hour, but normally that tutorial hour also I use for lectures because we have a lot to cover. Right? Throughout the lectures, I'll give examples. If it's a face-to-face lecture, this is actually the rule. Attendance, 3 times absent without reasonable excuse will be barred from taking exams. But I'm a bit flexible on this because you are adults now, so you should know that whether you should attend your lecture or not. I'm not going to bar you from taking exam, but of course, if you don't attend the class, the lecture, you will not be able to understand the material, so you fail the exam. So make sure that you attend the lecture and you ask questions if you are not clear. And I like to caution you that there are a lot of failures for this subject. There are a lot of failures. There are students who fail because it's quite difficult for the mechanical engineering students to grasp the concept in electrical engineering, because electrical engineering, the subject matter is not you don't see it in a physical form as you see in mechanical engineering. It's more like what do you call it? It's more like a concept which is you have to imagine in your mind. The only thing that you can see, maybe if you go to the lab, you hook up the oscilloscope, the spectrum analyzer, then you can see the signal. If not, you will not see the signal. Just like electricity. You don't see the current flowing in a wire. What you see is just whether the light is on or off. You see whether the fan is rotating or not, but you don't see the current. But in this course, we'll talk about voltage, current, and whatnot. You can only see those by hooking the voltmeter or ammeter. Then you can see the value. If not, you don't see. So it's quite sometimes quite difficult for mechanical engineer, engineering student, to imagine what we are going to study in this subject. So at the end of each class, maybe we have quizzes. So it's up to me whether I want to announce we have quiz for that day or not. But for the online lectures, normally I will give a take-home quiz. Basically, that I give you 24 hours to answer the quiz and submit through email to me, or submit through the MS Team to me. So most probably that during this online lecture this semester, I'll do that, right? And of course, students previous semester, they say that on what do you call it, take home quiz is more difficult than the normal quiz. So no sleeping during lectures and be punctual. For a face-to-face lecture, hopefully not more than 10 minutes late. With other lecturers, maybe they will not allow you to join the class. But for me, even if you are late, if the lecture is 2 hours, you late by 1 hour also, please come. At least you will learn something for the next 1 hour. So I don't bar you from joining the lecture even if you are late. Right? I am of the opinion that you should be able to join the lecture anytime that you're able to join. Right? Okay. So that is the basic introduction. Before that, did I show you the? I think this is actually my. Wait. I think so. This is the. My office is actually at the level 7. Level 7 in Bistari building. For you who are on already on campus. If you are still not on campus, you will know later. Okay, now, any questions so far?
No, sir.
No,
No, sir.
No,
So,
sir.
Now I'm going to share. Now I'm going to share the first lecture slides. Can you see the chapter 1?
Yes, sir.
Okay.
Yes, sir.
So this is the first chapter in your textbook. And that is the textbook, the photo of the front page of the textbook, Fundamental of Electrical Engineering by Giorgio Rizzoni. And the first chapter is on the unit and measurement. Introduction to Electric Engineering. Okay. The systems of unit that we are going to use in this course is the International Systems of Unit, SI, which is based on the 6 fundamental quantities. So what are those quantities? They are length, mass, time, electric current, temperature, and luminous intensity. So the units for length is meter, the symbol is M. Mass, unit is kilogram, symbol is kg. Time is second, symbol is S. Electric current is ampere, symbol is A, capital A. Temperature, the unit is Kelvin, symbol is K. Luminous intensity is candela, the symbol is C, small ct. Why the electric current and temperature, the symbol is capital A and K? Anybody know?
Because it was the SI unit for the unit.
It's because it's the initial of a person.
Oh.
Ampere is a person. Kelvin is also a person. So symbol is the capital. Same thing with hertz. Hertz, the frequency that we measure using hertz, which is 1/s. Hertz is a person called hertz. So the symbol is capital H, small z. So any units that we use the name of a person, the symbol, the first letter will be in capital. Okay? Remember that. These are the standard prefixes that are employed in SI units. Atto, A, symbol is A, basically that is 10 to the power of minus 18. Femto, F, 10 to the minus 15. Pico, P, 10 to the minus 12. Nano, N, 10 to the minus 9. Micro, the Greek symbol micro, 10 to the minus 6. Milli is small m, 10 to the minus 3. Centi is C, 10 to the minus 2. Deci, D, 10 to the minus 11. 10 to the minus 1. Deca is DA, is 10. Kilo is 10 to the power of 3. Mega is 10. The capital M is 10 to the minus 6. Giga is G, 10 to the power of 9. Tera is E, 10 to 12. So if you look at, let's say if you buy a hard disk, so now it's in the terabyte. So the sign is a TB, tera, T tera, yeah. If you buy what do you call it, the USB drive, maybe it's in giga, G, okay? So gigabytes. So this is the standard prefix that we are going to use. These are the derived units commonly used in electric circuit theory. Electric charge, the unit is coulomb. So the symbol is a capital C because he is a Mr. Coulomb. So it's a name of a person. Electrical potential is volt. Symbol is capital V, is Mr. Volta. Resistance is ohm, is the Greek sign of ohm. Conductance, now it's called Siemens, capital S. During my time when I studied this course, it was in 1984. So we don't call it Siemens at that time. We call it Mo, MHO. It's a reverse of the ohm, and the symbol was the what do you call it? They flicked the ohm sign. So that was in the old days. Now conductance is called, the unit is Siemens, S. Inductance is in Henry, capital H. Capacitance is Mr. Faraday. So the symbol is capital F. Frequency, Mr. Hertz. So the symbol is H. Z. Force, Newton, capital N. Energy or work, Joule, capital J. Power is Watt, capital W. Magnetic flux is in Weber, capital W, small b. Okay? And magnetic flux density is Tesla. It's one of the famous scientist or engineer, Nikola Tesla. So the symbol is capital T. So these are all the derived units commonly used in electrical circuit theory. We are going to use this over and over and over again throughout these 14 weeks. Okay, clear? Any questions so far?
No, sir.
No, sir.
No, sir.
So, what is an electrical circuit? Electrical circuits is a network that has a closed loop, giving a written path for the electrical current. So, it's a loop, it's a closed loop where the electrical current can flow. Let's say you have a source, then it will flow out from the source and come back to the end of the source. So it's a closed loop. If it's not a closed loop, it is not an electrical circuit. A network is actually a collection of elements through which current flows. So this is a collection of elements. So in the circuits, you have those elements. What are the elements that you have? Power supply, whether it's a current supply or whether it's a voltage source or current source. You have this source. Then you have the resistors. So those are the elements. You have inductors. You have capacitors. Those are the elements. These are what we call the elements of the electrical network. Examples of the elements. Yeah? So these are the main circuit elements. The elements you can divide into two: active elements and passive elements. Active elements characterized by this characteristic, which is the first one, is that it can generate energy. So it generates energy, it produces energy. And typically active elements are voltage and current sources. For example, batteries, generators, and transistors. Okay, so these are the active elements. Right? The passive elements, it does not generate energy, it absorbs energy. Okay, the common passive elements are the resistors, capacitors, and inductors. So you have to remember that when you talk about elements, you have two categories: active elements and passive elements. Active generate energy, passive absorb energy. Okay, active energy, active elements, batteries or current source or voltage source, generators which generate the electricity, a transistor which is can boost up the gain of your signal. Passive elements, it absorbs energy. So resistors, capacitors, and inductors. So if you touch the resistors, maybe feel the heat, a bit hot, because it's what I call it, radiates the energy. Yeah. So the symbols. Okay, capacitors and inductors, basically that the passive element which can store the energy. There is the difference between capacitor and inductor. The resistor will not able to store the energy, but capacitor and inductor, they store the energy. So it has that capacity. They have that capability. Okay. So you can use this maybe as what do you call it, as a temporary battery. So when you don't have the main battery, then if you have the capacitor is fully charged, it can still what do you call it, release the energy for a few seconds to your circuits. So that is where we study about transient response later. So that's why we study RL circuits and RC circuits, because L and C's store some energy that can flow, can produce current and flow in your circuits. So we will do those kind of analysis later. So now we go to the source type. If you look at the diagrams, okay, those are the symbol for this control, voltage control, voltage source, current control, voltage source, voltage control current source, and current control current source. So you have a diamond shape. If it's you have a plus and minus sign, that is actually the dependent voltage source. And if you have an arrow inside, there is a dependent current source. Right? And those are the kind of relationship that you have. I'm not going to go through that. Okay. These are the symbols of the elements. Okay. If you have a plus minus inside of the circle, there is an independent voltage source. If you have a plus minus inside of the diamond, there is a dependent voltage source. If you have an arrow, if you have an arrow in a circle, is an independent current source. An arrow inside of the diamond, this is the dependent current source. This is the symbol of the resistor, wiggly lines, which are resistor, and this is the passive with the coil and with the symbol L is the inductor, and the last one is a capacitor where you have two lines, parallel lines. Sometimes we draw two parallel lines, sometimes we draw one parallel line and with the curved line. So this is a capacitor, it's the same thing. Okay? A dependent source is an active element in which the source quantity is controlled by another voltage or current. Okay, so they have four types: VCVS, CCVS, VCCS, and CCCS. So these are all the dependent source. Okay? And the relationship we saw in the last slide just now. So that is what we cover in chapter 1. Any questions so far?
No, sir.
No, sir.
No question. Okay.
I think no, sir.
Simple, right? So that is chapter 1. Now we go into chapter 2. Okay. You can see the chapter 2. Fundamentals of electric circuits.
Yes, sir.
Yes, sir.
Okay. Principal elements of electrical circuits. I've mentioned about the independent sources, which is currents and voltage sources. It has the capability of generating a prescribed voltage or current independent of any other element within the circuits. So this is actually the main source of your energy. You have voltage source and or current source. This source may output a constant voltage or constant current, or they may output voltage or current that varies with time. If it's constant voltage or current, this is called DC. If it's varies with time, this we call a AC, alternating current. If constant, we get direct current, DC. So these are the ideal voltage source. An ideal voltage source is a two terminals. Okay, it has two terminals. You have plus positive terminal and negative terminal. You see at this this circle with a plus sign and minus sign. So it has two terminals. plus terminal and minus terminal. Plus terminal is positive terminal. Minus terminal is a negative terminal. So it's a two terminal element that maintain the same voltage across its terminals regardless of the current flowing through it. So this is an ideal voltage source. For example, if it's 10 volts, let's say V0 is 10 volts, so therefore it's throughout, no matter what current flowing, and the voltage is always 10 volts. Just like you buy a battery, the AA battery and whatnot. So across that battery, you have a certain voltage. So VT is constant no matter what the load current is. So it's always constant. That is the ideal voltage source. Another one is an ideal current source. An ideal current source is also a two-terminal element that maintain the same currents. If voltage source is same voltage, maintain same voltage, in ideal current source, it maintains the same current regardless of the voltage across its terminal. So the symbol of an ideal current source is a circle with an arrow inside. So the tip of an arrow is the positive terminal, and at the end of the arrow is the negative terminal. So the flow of the current is according to the direction of the arrow. Okay, so IS is constant no matter what the load voltage is. So the current is constant throughout. Okay, there is two sources: ideal current source and ideal voltage source. Now we have dependent sources. So the dependent sources also, we have dependent current source and dependent voltage source. Dependent sources are whose output, whether it's current or voltage, is a function of some other voltage or current in the circuit. The symbols typically used is this diamond shape. Right? Now, these are some other terminologies that you need to understand and you need to remember. So some of the, in the exam, in the test 1 and finals, we ask you to give the definition of these terms. For example, branch. Branch, or Americans say branch, is actually any portion of a circuit with two terminals connected to it. So these are the examples of the branch. So basically, the branch is a circuit with a two terminal. Okay, a branch may consist of one or more circuits element. So as long as it's a two terminals, it's called a branch. So this is a resistor. This branch consists of a resistor, and this branch consists of a battery. And this branch is actually representing an emitter, which consists of the emitter and internal resistance. This is a practical emitter. So you have two elements here in the branch. So you can also have 3 or 4 elements in a branch. So if you see like this, this is a branch. So basically that you have a branch and you have the two terminals, positive and negative terminals. That's a branch.